Hi friends, welcome back. Today we are going to solve Leetcode problem count words obtained after adding a letter. The problem number is 2135. Before we start looking into the problem details, some examples and the Java solution for this problem, I want to mention that my channel is dedicated to help people in their Java interviews and in their coding interviews. On my channel, you will find a lot of helpful videos that can help you in your Java interview and coding interview preparation. There are over 300 different varieties of solved problems on my channel that are taken from previously asked coding interview questions by big tech companies like Google, Amazon, Apple, Facebook, Microsoft, Yahoo, and many other big financial companies. Those are like varieties of problems including BFS, DFS, matrix problems, graph problems, problems related to strings, linked list, dynamic programming, optimization problems using priority queues. A lot of problems that includes like solutions based on data structures such as tree set, hash map, priority queues, stacks. So you will find vast varieties of problems that can give you good preparation for your coding interviews and Java interviews. So please subscribe to this channel now. So let's look into the count words obtained after adding a letter problem statement first, and then we'll look into some examples and we will formulate our solution. You are given two zero indexed arrays of strings start words and target words. Each string consists of lowercase English letters only. For each string in target words, check if it is possible to choose a string from start words and perform a conversion operation on it to be equal to that from target words. The conversion operation is described in the following two steps. So append any lowercase letter that is not present in the string to its end. For example, if string is ABC, the letters A, D, E or Y can be added to it, but not A. If D is added, the resulting string will be ABCD, right? So ABC is the original string. So we can add a letter which is not ABC, right? So you can add D or E or Y, anything except ABC, right? So which means that same letter you cannot add basically, right? And rearrange the letters of the new string in any arbitrary order, which means that if you add, let's say, D into this ABC string, right, then it becomes ABCD. So you can rearrange this ABCD in any way, right? ACBD or BACD or CBDA, any way, like you can rearrange it. Note that it can also be rearranged to ABCD itself, or you can just leave it like this basically, right? You don't have to rearrange it. Return number of strings in target words that can be obtained by performing the operations on any string of start words. Note that you will only be verifying if the string in the target words can be obtained from a string in start words by performing the operations. The strings in start words do not actually change during the process, right? So they have given it already. So they have given us like two different examples here. Let's look into the constraints. Is the start words length is between 1 and 5 into 10 raised to 4, so it is very big length, right? Target words also can big length. After that, every word in that array can be between 1 and 26. Each string consists of lowercase English letters only, and no letter occurs more than 1 in any string. So it means that all the letters will be unique, right? So they have already given that to us. So let's take this first example, and act tag. So this is given as a start words, and in the target words we have given tag, act and acti, right? So let's take this example on the whiteboard. So this is the first example they have given us. So as you can see, first let's just visually solve this problem, and then we will develop our algorithm to how we can like solve this using Java, right? So basically the problem is that we have to like take, for example, if you take this word, right, TACK, right? So TACK. So we can rearrange this word. So what we can do is we can rearrange this word so that this word can be formed by start word, right? So that's what we have to find out, if it can be formed or it cannot be formed, right? So if we take these three characters A, C, T, then this one is an additional character that is added basically, right? It is added to this target word. So we can just rearrange this TAC basically, right, into ACT, right? And ACT is already given into the start word, right? Which means that we can form this word TACK from ACT, correct? So this is one word that we can form with the start word TACK. So we will count it as a 1, right? So this is one word that we can form basically, right? TACK. So other word is ACT, but ACT we cannot form from start word, right? Because we have ACT here, but we have to add something into this, right? We have not added anything, so it is as it is, so we cannot take that as it is basically, right? Because they have given in the problem the conversion operation, right? So it means that we have to append something there, right? We are not appending anything into this ACT in target word, right? So this one cannot be taken into the answer as a count into our count, right? So now let's take ACTI, right? So let's just write this ACTI, right? So let's write this. So now again this word we can let's say we have appended I here, right? But we already have this ACT word here, right? So ACT is in the start word, right? Which means that we can count this word, right? So this word we can say that this is a kind of derived from the start word, right? By adding I at the end. Here we don't even have to find out any rearrangement because the word can be, you can find it as it is there, right? So this is the second word, right? That can be found out using the conversion rules. So that's why, as you can see, the answer will be 2 here. So the output is 2 here, right? So this is the problem basically, right? So you got the problem, I think, right? So basically we have to find out in the target word some word that can be formed using the start word, right? And then using the conversion rule. These are the conversion rules. So we have to append some character, then we can rearrange, right? So how we are going to solve this problem now, right? So what we can do is, first we will take these start words, we will read all these words and act, tag, right? And then first, whenever we are reading it, we will first sort the characters in this word and we will store it into a hash set, right? So after sorting, ACT will remain as ACT only, right? After sorting, ANT will remain as ANT only because they are already sorted, A and then N and then T, right? When we are taking the TACK, we will sort it like this, right? So after sorting, it becomes ACKT, right? Because it will follow the alphabetical sorting order like A, B, C, D, E, F, G. So that one we will sort, right? So this one become sorted like this basically, right? So we will first sort it and we'll keep it in a hash set, right? After we sort it, we will go to the target word, right? So let's say this is let's go one by one. So we will just take the TACK word. First TACK will be there, right? So we will read this TACK. So what we will do, if this one can be formed using these conversion rules that they have given us, these two conversion rules, what we will have to do to find it out is we will first sort this word from target word so that each character will be alphabetically sorted. So let's sort this word, right? So after sorting, it becomes ACKT, right? This is sorted word. So after sorting, what we will do is we have to basically what we are trying to do is we want to check if after conversion rule that string can be formed, right? from the start word, right? So what we will do is we will remove each character in this string and we will check if that remaining string is there into our sorted set, correct? So for example, we will first remove a, right? Then we will first check if ckt is there here. There is no ckt here, right? No ckt. So here as you can see we are checking, right? Ckt first, we are checking ckt, so ckt is not there, right? After that we will remove the second character, right? Now it becomes akt. So akt is also not there here, right? So we are checking akt here, as you can see, right? I just gave you a stack trace so you can formulate like how step by step the code will work, right? So akt is not there, right? So after that we will remove k, right? So act, so is act there? Yes, act is there here, right, into our sorted set. So once we find any character into our sorted set, we will make our count. So count will be, so let me remove this. So count will be 0 in the beginning. Now we found act here, right? So we will increment the count to 1 as we are here, right? We are checking act because we removed a k character, so it became act, and we found act into hash set, so we will increment the count. Now let's take another word, act. Now once we find the match, we will just break out, right? Because we already found the match. Now we will take act word. So let's take act now. So this is already sorted, right? So there is no need to sort, it's already in a sorted way. So now again we will try removing one by one. So we will remove this character a. We will check if ct is there here. No, in the sorted set. So ct, we are checking ct here, right? Ct we are checking, ct is not there, right? So okay, then we will remove c. We will check if at is there here into this set. At, no at, right? So no at is there, we are checking at is not there, right? After that we will remove t. Now we will check if ac is there here. ac is also not there, right? We checked ac also, so ac is not there. So we are exhausted, right? We tried all the possibilities of removing one character and checking into the hash set. We did not find any match, so we will not increase the counter, right? So we will move to the other word. So act, we already are done with this one, right? So far we are done here. Now we will go to the next one, right? act. So ac, here we are from the target word, we have to take acti. So we will take acti now. acit, sorry, because after sorting it will become acit, right? So we took acit. After that again we will do the same logic, right? We will remove this a and we will check if cit is there in the sorted set. No, right? So we checked cit here, right? So cit we didn't find, we will remove c. Now ait is there, we checked ait is also not there, right? Then we will remove I. Now act is there, yes, act is there here into the set, right? So act we are checking, act we found, we will increment our count to 2 and we will break out, right? So which means that two words we can in the target words can be formed using the conversion rules from the start words, right? So this is the problem and this is the solution. We are going to use this logic using the hash set and the logic that I mentioned you. So this is the how we are going to solve the count words obtained after adding later problem. We will take one other example into our unit test case. So here in this example you can see that this first word ram can be formed like this. Target word can be formed using this one, right? Because you can see r is there, a is there, m is there, ram, all these are there here, right? With one additional character y, so that word can be formed, right? Mary and ram can be formed. Mary can be formed using ram, right? So there is one counter, so that is count 1, right? I'm not just explaining you all the sorting thing now, because it will become very long if I explain sorting, but you can just you understood that we will first do the sorting and we will put it in a hash set. This logic you understand, right? So same thing we will do here. This is another example that we will take. Now here also the second word SAM is there. Here also you can see SAM is there, right? So K, we have done additional K added, right? So which means that this target word can be formed by using the source word, right? So we will increment count to 2, so 2 count, and here also last one MAN can be formed. As you can see, MAN is here also, but additional Y is added, right? So it became many. So there are all the three words can be formed basically. So let's go ahead and now take a look at the Java solution for this problem. So first we just defined a hash set of strings. Then we iterated through startWords array and we just sorted each word here, right? Sorted each word, and after that we just added the sorted word into our set, right? So this is the sorted word into our set. So this step we are doing basically. So I'll just remove all this coloring so I can reuse this space. I think you already understood the logic. So this step we are doing. So we are reading from the start words, we are sorting and putting into hash set. So once we are done, then we will define one count variable. It is 0 in the beginning. We will iterate through each target words, right? We will sort that word here first, and we are actually simulating that here in this for loop we are simulating that we are taking out each one by one character. For example, if it is a TACK, right? So first TACK means we are reading this, so it will become ACKT, right? ACKT after sorting, right? So we will what now we are doing in this for loop is we are simulating removing this word first, then this word, only one character, right? Sorry, one character, first character, then we will simulate second character removal, and we will simulate third character removal, we will simulate fourth character removal, and we will keep doing it until we find a match into our hash set, right? So that is what we are doing into this for loop. As you can see, this inner for loop, this goes from j is from 0 to I, less than I, right? So and j, again this one here, j is equal to I plus 1 to until the end of the word, right? Which means that we are simulating that we are removing ith character basically, right? Removing ith character, and then we are checking here if the after ith character removal, if set contains that string, set contains that word, right? If it contains, we will just increment the count and we will break, right? Once we find a match, we don't want to continue, right? We'll just break out and we'll go to the next word, right? So at the end we'll just return the count. So this is the solution. Let's go ahead and we'll just run this test case, which is the given by them, the first example that we just saw. We'll just make sure this works. So we are getting correct answer, 2 is expected and 2 we are getting. Let us take the another test case that we have here, the same test case. So I think I already created here. So yeah, I can just update this one. The first one is Sam and this one is man, and this one is Mary. The second one is mask, and the third one is many, right? So let's go ahead and run this one also. So all three target words can be formed by using the three, like the source words, right? So this is the logic that I explained you. This is how we can solve count words obtained after adding a letter problem with the help of hash set and the logic I explained you. So if you are new to my channel, there is a dedicated Leetcode and Leetcode solution playlist which has over 200 different varieties of solved problems explained with whiteboarding sessions, examples and Java code solutions. Those problems are taken from previously asked coding interview questions by big tech companies like Apple, Amazon, Microsoft, Yahoo, and like like Apple, Amazon, Yahoo, Microsoft, and many other big financial companies, and those constitute very important coding questions varieties such as DFS, BFS, matrix problems, string related coding questions, graph related problems, binary search tree related coding questions related to optimization, priority queue, tree set, hash map. All these different varieties is covered, so it will give you really good preparation for your coding interviews. If you like this video, if you find this content helpful, and if you like the way it's been explained with whiteboarding session examples for easier understanding, then please give it a like. Also subscribe to the channel. Your subscription to the channel is really important for the channel, because that is the way the channel can grow and reach to more people who need help in solving coding problems. The main goal of the problem is to help people in their coding problems solving and in their Java J2 interviews. They can also watch these videos and understand how to approach different coding problems and how to use Java and its APIs, classes, and libraries to solve different varieties of coding problems. So if you find this content helpful, if you like this content, then please give it a like and share this content with your friends and colleagues. I'm gonna give you the link of the GitHub account for this solution. You can check it out on my GitHub account. There are lots of solutions of lot of like Leetcode problems and other problems from code forces, code chef. So you will find a lot of varieties of problems solved and explained for easier understanding that can definitely help in your interview preparation. And thanks for watching this video.